Hi, welcome back to the course on Guide to Computer Forensics and Investigations. And today, as part of the lab exercises, we'll be covering a software called FTK Imager. That's one of the best softwares if you want to create an image of a hard drive. The hard drive which you are investigating, it could be an internal disk or it could be an external disk like a USB connected device. If you want to download the software, you can go to their website and download FTK Imager. You'll have to fill in a form in order to provide some basic information what you'll be using this software for, and it's available for free. And you can conduct some basic investigative analysis on the software. Now, this is the initial interface of the software. You can do lots of things. For example, if you click on File, you can add an evidence item, the evidence which you have already created by creating an image of the hard drive or any other physical disk, or attach the images to the device. So whenever we are working on this software, the first thing that we do is we create an image of a disk. Now, this screen asks you that what's the source of the evidence type, whether it's a physical drive, logical drive, image, contents of a folder, or it's a DVD or a CD drive. Now, the difference between a physical and a logical drive is physical drive is any other hard disk which is connected to this machine physically, whereas a logical drive are the partitions on the same hard drive. In order to explain it, if we'll see the disk management on this computer, we have a disk 0, disk 1, which are two different disks. Now, disk 1 is a USB disk, which I have connected, on which we'll be conducting our investigative analysis today, which is of 8 GB. So that's a physical disk because it's a separate disk. Disk number 0 is also a physical disk, but these partitions which are appearing on disk number 0 are called logical disks. So if you are conducting an analysis on one of the partitions on the same computer, you'll be selecting logical drive. But if you have connected an external disk or an additional disk to your computer, you'll be doing the analysis for the physical disk. Now, images, if you have already created an image and you want to just attach it, or the contents, CD or DVD drive. So in our scenario today, we'll be conducting analysis, or we'll be creating an image of a physical drive, which is a USB pen drive of 8 GB. So we'll select a physical drive, we'll press next, and it would show us only two drives. One is VMware, since it's a virtual machine, and the other one is a USB which is connected to this forensics workstation. As you can see that it's showing 8 GB, and whenever you are trying to reach any physical disks on the computer, Microsoft shows it with this sign with the backslash and physical drive number 1, which is USB stick of 8 GB. We'll press finish, and now it has selected the drive over here. It's asking for a destination where you want to save the image of this pen drive. So we'll select add. Now here we have different formats that we can choose from. RAW DD is the most common format which is used for imaging the external hard drives for investigations, etc. Smart is used for Linux-based operating systems other than Windows. E01 is quite famous as well. It depends if it's a proprietary software, and it's asking for a format of E01. We'll use it. AFF is also a proprietary format. It's an open source format which is used, or which was used before, but not lots of softwares are covering AFF these days. So we'll be keeping the image format as raw DD, and then we'll press next. Here we'll provide the case information. Now, this piece of information is very important whenever we are conducting any analysis on a disk, because we'll have to identify that which disk is it, and how can we identify it in future if we want to. So we'll say it as case number 001, evidence number 001-2021, or if you want to be very specific, we'll have it on 9th month of 2021. Unique description, imaging of USB drive, and then examiner, Mr. XYZ, whatever your name is, and then the notes is for testing purposes. Press next, and now it's asking the destination where you would like to save the file. So I'll select the browse, and we'll go to this computer, and on the data drive I'll create a folder over here called USB, and I'll select that. Here we'll give the name of the file. For example, we'll call it as USB, and we'll call it USB, and then we'll use the same naming convention as 001, and then we'll say 09/2021. Now this next segment, image fragment size, it's really important if your hard drive is huge. For example, if you are creating an image of an external hard disk of 1 terabyte, it would be difficult to move it from one machine to another. So in order to control that, we can split the image into different segments so that we can move the files together one by one easily. Now you can create the segment size depending on the size of your hard disk which you are investigating. I'll keep it as 1500 as a default one. And if you want to compress the image, you can use the options from here from 0, 1, or 2. But I'm not going to compress it at the moment because I want to keep my image intact without any compression or anything, because whenever you are compressing an image, it takes time to compress it, and if you want to analyze it again, it would take time again to decompress it. After that, we'll press next. Now here it's asking you to verify the image after the image is created. It's very important to verify it. Pre-calculate the process statistics and other things. If you want, you can do it. Otherwise, this one option is more than enough, where it would verify that the image is successfully created. Now, once that's done, you'll press start, and it would start the imaging process. Now, if you want to check that, you can go to the D drive of the computer and select USB, and you can see that it has started creating the image file at this location. We'll have to wait it till it will finish, and then we'll continue. Now, as you can see that it has created the image successfully and has verified it. As you can see, the computed hash code, both of them are matching with each other. So that's perfectly fine. Then it's even checking for the SHA code of it, which is SHA1 computed, and then report hash, which is verified, and there are no bad blocks found on the image. So that gives us a verification that our image has been completed successfully. And if you remember, we created different segments of 15,000. So that's the size of the files it has created. Make sure that all of them are available in a sequence, because if one file is missing, we won't be able to load the image. Now, out of all these files, we have one text file appearing over here. And if we'll open it, it would give us the image of the FTK imager, which is very important because we need to find out that which version was used in order to create this image. The case number, the evidence number, unique description that we provided earlier. Then it's giving the information that where the image has been created, the physical evidence of it, number of cylinders, sectors, all that relevant information. That again, MD5 and SHA code is appearing for verification, and it's even showing the starting time of it and ending time, and then the different segments that it has created, and it's ending the file over here. So that's how we create an image of a physical drive which is connected to the computer. Now, if we want to mount the image, we'll go to the image mounting, and then we'll select the file that we have just created. Let's go to the D drive of the computer, on this computer, on USB, and we'll select the first file only, and it would mount the other respective segments of it with it. Now, Just keep an eye on one thing, that when we'll go to the file explorer on this machine, for example, if we'll go to this PC, we have only C drive, D drive, and the target F drive is appearing in this machine. And in disk management also, you can see disk 0 and 1 is appearing. 0 has 2 partitions, and the disk 1 does not have any partition. But once we mount a drive, it would show us another physical disk in the computer. Okay, so here we have selected the first file. It's saying the mount type. We'll say we want to keep it physical or logical. So if we have a combination of it, we can select it. But mount type, we can keep it as a physical only. And then it's asking us that what's the method, like block device, read only or writable. So since it's a forensics image, and as we know that we don't want to alter the image by any means, we want to protect the evidence, so we'll keep it on the read only format. And the drive letter which would be associated with this one would be drive letter G. Once that's done, we'll mount the drive. Now, as you can see, the drive has been mounted, and we can close this thing. We can see in disk management that a device has been added. As you can see, a disk 3, which is added to the computer. And if we'll go to this PC in the file explorer, you can see the target disk, and this is the G drive. It would have same contents, 41 items, and in this one also we'll have 41 items. So a complete replica of it has been created. But if we'll try to delete anything from it, let's see what happens. You don't have an option over here. And if we want to create a new file, there is no option appearing in this one. Whereas if we'll go to the actual disk, if we'll right click on it and create folder, we have an option. And if we want to delete a file, it would let us delete the file. So that's how we create the image on FTK Imager. So once the image is created, now we want to add the evidence over here in order to see the contents of it. So for that, we'll click on add evidence item. And since we have already mounted the drive, so it would be a logical drive on this computer. So we'll press a logical drive, press next, and we'll select the logical drive G, which we have just created, which is read only. And then we'll press finish. If you'll see over here in the evidence tree, you have the disk appearing, which is FAT32, and then we have the items of it or contents of the drive appearing over here. And now in the hexadecimal, you can find the information about the files which are appearing. Further, if you'll drag down, you'll find unallocated space. And since we have it empty, we have a size of it. You can further check if there is any information which was appearing on it. So that's how we mount an image and we browse the contents of it. If you'll find some folders over here with a cross mark on it in a red color, it means that that data has been deleted, which can be recovered as well. Further, if you want to find the hash of the entire disk, you can export the hash, or you can right click on it and you can export the hash of the respective folders or certain categories. So if we want to create a hash of the disk over here, we'll export the file hash of all the hashes of the files inside the computer. We'll simply click on export file hash list, and we'll select the same USB location where we were saving it, and we'll say it file hash list, press save, and it would create a hash list of all the files which are there in the computer. So the file hash list has been generated. We'll go to the D drive where it has created, and we'll open it in Notepad++, and we can see over here the MD5 and SHA hash codes are appearing, then the target drive and the file name. So for all respective files, we have the hash code available with us now. Now, in case if you are looking for